As she picks it up, she drops it everywhere. And that's fine. People do that all the time. But she screamed at the top of her lungs that I thought she would die.
Okay, let's get started.
As
much as I want to continue this. Okay, here we go. So we've got, actually, I put an announcement up on Blackboard. We've got 3 exams left. One of them is, the first one is the post-test. You remember taking the pre-test? Now it's time for the post-test. That's Monday through Wednesday of next week, December 3rd, 3 through 5. It's in PSA 21. You're not going to prepare for that, okay? We've been preparing for it all semester. All right, it's a required element, of course, and you'll get bonus based on how much you improved from the pretest. Woohoo! Okay, so and it's you'll see that it's all concepts and ideas that we've talked about all semester. Okay, so based on your improvement, you'll get some bonus on exam 3. Just like based on your score on the pretest, you got some bonus on exam 1.
So the testing center is open from 9 to
10:30 to.
oh, it's 10:30.
Yeah, so testing center, which is for that and Thursday's exam, 10:30 a.m. to, so that's when you have to enter by. But you can, I think they collect tests around 8:15.
When does the tutoring centers close for the semester?
I will let you know that, but it's definitely open all next week.
All next week?
Yeah, for sure. Okay, so the testing center, you can enter as early as 10:30. You have to be in the door by 6:30, as you know. It's the same procedure as always, and then you can work till 8:15. You need to have your Sun card. So the post test, don't forget, Monday through Wednesday, and then Thursday is our exam 3. And before I talk about that, then the final exam is then a week. The first day of finals, a week from next Thursday, so 2 weeks from yesterday, the 13th. All right, here's the location. SCOB. Is that some business building? What is that? What's that? Schwada building. Is that kind of across from the bookstore? Kind of a little bit east and across the street from the bookstore. Okay, 210, that's a big lecture hall. 7 p.m. Be there at 7 p.m. We'll start at 7:10. Okay, so be there by 7. Questions about exam stuff? Okay, I posted the folder for exam 3 and exam prep. You've got the concept and skills outline, just like the other exams, and then an exam 3 quiz archive that may have a quiz or 2 that we didn't take. This just last semester's quiz archive. Yeah, I'll give you ways to prepare for the final. Okay, so this is now up. This in exam prep, you've got your folder for exam 3. Also, web work is up and running. Ready for you to work on. Don't wait till Wednesday night, okay? So if you go to web work, exam 3 review problems, only 44 this time. Notice there's you get either 1, 2, or 3 attempts, okay, per problem. Notice especially the ones that here's one with 5. So it's different on all questions. Some of them, just want to point out, some of them you only get 1 attempt. So, because you got to get it, or either you get it or you don't, all right? Then others have 2, 3, and 5. So just be aware of your attempts. And then it's, in terms of getting credit for it, it closes Wednesday at midnight. That way, after Wednesday at midnight, you'll have access to all the answers. Okay? Even after you exhaust your attempts, you always have access to the problems, and you can keep working on them.
And it'll tell you when you get them right, right?
Yeah, you get the green bar, right? So if you get the green bar, then you got it right, and you can go on. But whether it's before or after the due date, you can always have access to the problems themselves and work on them. Okay, any questions about web work? Okay, so we're gonna do the number 1 in worksheet 7, then we're gonna go back and do something in worksheet 6. So we started talking about all these terms related to sine and cosine curves. Sine and cosine curves can model anything in the real world that has repetitive behavior, not just circles. So we've developed the whole thing from circles, but anything in the world that cycles, that goes through cycles, can be modeled with sine and cosine. All right, so, or I should say many things, not everything, okay, but many things that have a cyclic behavior fit this profile of sine and cosine. Okay, so we're talking about these terms. Period, we've talked a lot about. Amplitude, now we defined last time. Midline, max, min. I think, is that everything? So you need to know what all these mean and how they relate to one another. So this is asking for the period and the amplitude. But so before you, in part C, you're going to define the formula for the function. Before you do that, go ahead and make sure you understand all these things relative to this curve. And then part C, you're going to try to write a function that would have this graph. Okay? So take about 3 minutes and see what you come up with on this. Just number 1. What page is that? On page 295, just number 1. Identifying period, amplitude, midline, max, and min.
I said the mess. Oh my God. It just is bad. Enough. It is. I think you're right. 3 to 7. This line goes from 3 to right here. The difference.
So compare with those around you.
Isn't the amplitude and period this
Totally different.
Yeah. One week. 1 week. Or no. The max. Or the max. Min is max. But
Amplitude is like where
I don't believe from a midline to max. And the period is. I've written down definitions of the max. Wait, from here to here? Here. Oh, so it starts with so it's here. To here? No, here. That's here. We have to define it. Let's see.
Do you want us to?
Yeah, go ahead and finish it. Yeah.
Just start with 2
Okay, what'd you get for the period? What do you think the period was? 4.2. So how did you get that? So where does this thing start? Right around here, right? So is it from here to here? No, you got to get a full rotation. So one way to look at the period is one full rotation. So they're saying about 4.2. Okay, another way to do that is, look, how far would you have to go from here to get one cycle? Where would you go? So this is like starting at the top of the circle. So starting at the top of the circle, we would make it all the way around when we got back to the top again. So if this is 5.2, and this is 1, in terms of the angle, so 5.2, 1, so then you get the same result, right? So you can go from peak to peak, or you could go from low point to low point. That would be the period. But when you do it on the midline, you got to watch out, because halfway through it crosses the midline, right? So if you're going to start on the midline to find the period, watch out, because it will cross the midline halfway and then make it back to the starting point of the cycle again here. So do you see that all those lengths are the same relative to the x-axis? These are all the same. They're all about 4.2 long. So that's all 3 different ways of measuring the period. Does that make sense? Okay? Amplitude. So let's start with the max and min. What is the value of the max? 3. This thing gets as high as 3. What's the value of the min? -7. This thing gets as low as -7. So the max is 3 and the min is -7. How does the midline compare to the values of the max and min? It's so easy, right? So it's going to be exactly halfway between those. Right? So exactly halfway between those. And how can we do that? How can we calculate that? So if these were weird numbers, right? Yeah, so it's like the average, right? So you're just going to find the average of those two. And this is a simple example. I'm just trying to, in case the numbers are a little less convenient. And so that would be. And that's, so -2 should be where this thing, it's like the midline. And it is, right there, -2. Okay, so then what's the amplitude? It's defined as, the amplitude is defined as what distance? From the midline to the max. Not from the min to the max, from the midline to the max. All right, so it's going to be the distance from -2 up to 3, or -2 down to -7. Which would be? 5. So as a calculation, so how could you set it up as a calculation of other things to get that number 5? What would it be? How would you get? So we're talking about this right here, this distance right here. But just in general, any curve. Max minus mid. Max minus mid, not min, mid. Max minus mid will give you the amplitude. So now we need the function. Now we need to find the function. So we look at the midline and look at the midline at 0 to help us to figure out which do we want to use. Why sine? Yeah, starts at, so this, we know this is what sine does. The height above the horizontal starts at 0, goes up to the top, back to the horizontal, down to the bottom, and back. So it'll be sine. Okay, so can we just use radius lengths, or do we have some multiplier that we need? She says the amplitude. 5?
Yeah.
Yeah, because the amplitude relate. If this is circular motion, the amplitude is simply what? Related to circular motion.
One radius.
The radius. One radius, right? Because we're going to start here. When we get to the top, we've gone up one radius. One radius length. So that amplitude is simply the radius. If it's circular motion, okay? So then, what does the parentheses represent? Angle, and we know that, and so this is going to have the form in here, it's going to be BT, right? And so we're using the period, and so in one period, which is 4.2, what angle should we rotate? 2 pi. So that the whole thing inside needs to be 2 pi when the x, sorry, this should be x. When x is 4.2, the angle that goes into sine needs to reach 2 pi so that we have that one full rotation. So the value of b then is 2 pi
4.2.
over 4.2. X.
You have to write it in terms of x.
See what happens when now, so look at that, just to check our answer. What would happen if we put 4.2 in for x? What would that equal?
Full rotation.
What would that value be? That's right. That value would be 2 pi. If we plug 4.2 in for x, that becomes 1, and we're putting 2 pi into sine, so we're getting to one full rotation when x is 4.2. Are we done? So this would be the height above what?
0.
And think about it in terms of a circle. It's height above. Try again. Horizontal diameter, right? Horizontal diameter. That's what this is giving us. So horizontal diameter would be like 0, but now our reference is -2. So the midline just moves the whole curve up or down. So look at this. What's the maximum value of sine? Just the sine part. What's the biggest it could be? How many radius lengths? How many radius lengths? It's the biggest it can be. Sine. 1. So when we get the max sine, what's the value of the function? 5 times 1 minus 2. Right? So the biggest that sine can get is 1 radius length, and we get the value 3. Well, that's the high point of our function. And what's the lowest that sine could be? Bottom of the circle. -1 radius lengths. Sine could be as low as -1 radius lengths, and that gives us the min, -7. Does it make sense? So how many people got it on the first try before I started? Raise your hand. 90% of it correct. So which part were you not able to get for my information?
Function.
Which part?
Function.
Well, the whole thing is the function. Which part of the function?
4.
The -2? Is that what you missed? So the midline, as you move the midline, it just moves the whole curve with it. All right, so we needed to move the midline. If we move the midline down 2, it moves the whole curve down 2. So without the -2, then this goes as high as it goes from 5 to -5, see? So without moving it down, our min is -5 and our max is 5. So then all you got to do is just, how far down does the midline go? That'll take the whole function with it. So the max will move down to 3, the midline will move down -2, and the min will move down to -7. Okay, so now let's go back and look at number 10 on the previous page. So you're starting by sketching there. You're going to start by sketching, then you're going to define the functions. See how that goes.
What did you read? Right? And now you're 2 feet. You're 2 feet above water, so you're going to move up 2. Just moving up.
Oh, this is your blue box. Isn't it? So it was right.
Oh. I know, it is too.
Oh,
That's what it's supposed to.
This is your baby.
because you're 13, yeah. So it's actually.
What's that? Yeah. Yeah. Right. Oh, do we have that? I'm just scratching it.
Okay, you're graphing the height of the bucket above the water. So forget about just visually imagining what the bucket's doing and graphing its height above the water. Okay? So don't worry about creating the formula yet in part A. Getting a visualization of the height of the bucket above the water. Above the water. You want me to check? So let's get that. You got to get that picture right before you go on to part B. So do you want me to check? I can check.
What you want to do is you want to take 11, multiply it by 2 pi. That gives you the length of the whole circle. And then you want to divide that by 4, and that'll give you how far it travels each quarter. So 17 is what I got.
Is 1 quarter.
Yeah.
So we divide this, so the first point is 17.
Or,
Yeah.
how, isn't it better?
And then you would add another piece. Or another
This
tax,
one.
or another tax.
Okay, so it starts with
Yeah.
B, and then
Well, I
it's
said,
after the first picture.
this is the
Four, five. So you
That's
took
how
the whole
far it's traveled.
Oh, I see.
How far it traveled.
You can figure it out. Just think about this. Okay, we're going to start with 3 bar, how high is it?
And then if you want to graph it, you can divide by 14. And that'll give you like, or no, not 14, divide by 4.
You have to worry about is
That'll
the
give you like first length. And then if you multiply it by 2, it'll give you the second length.
Just consider where the bucket's at the midline at the top, and the midline at the bottom. The midline at the top, the midline get the sketch. You don't have to worry about the specifics in between.
Like is this kind of line?
So you tell me the bucket goes underwater. She's showing me that it goes underwater. So at the low point, how high is it above water? Yep. Go underwater? Bucket gonna go underwater? Oh.
By default, when you add these two, you have to be weird.
So the line doesn't.
Your mids.
Minced.
That's what I just said.
I know.
Your mids.
That's the max. We
Yeah.
use
No, I wasn't scolding. I was just like,
It's very East Coast to be that you
scold? I'm not scold.
When I was your age, I was
Like the.
Oh, so it's a maturity thing. Is that what you're saying?
it's
Yep.
an East Coast.
So 13 would be your mid, right?
No, it has to be your mids.
13 would be your mid.
How can you go higher than that?
Because this is 11 right here, right? This is 2, so 13.
Get that graph right before you go on. Make sure that graph looks right.
11, so now you're at 24.
so
Would be your
24 is the max.
because your diameter is 22. Plus 2, 24. So the highest you can go is 24. The lowest you can go is 2.
Your radius.
No. It's
You
not
can only
13.
go one radius.
Your math, well, one radius length is 5, which is your midline minus your max. I don't know what a midline is yet. But yeah, I don't think it's,
Highest you can go is
24.
highest you can go is 24. Because 13 is 7 your mid, because you're right here when you hit 13. Because this is 11. And plus 2, 13.
Make sure you get that picture right.
Right? Am I right?
How high is it when it starts above the water?
13.
13. What does it do next? Where does it go next?
It goes up to 24.
Up to how high?
24.
24. That's what you need to do. So it starts at 13. In a quarter circle, it'll be up at 24. Keep going like that.
2 is as far
Yeah.
as 24 is as high as you can.
Okay.
So it starts at
Yeah.
So I was right.
so at 17.27 it goes
I said, how does it go up?
up.
Yeah, there you go.
Past
You know,
the
you know in general what those look like.
So
Almost done.
it goes like
Well, you can get, at least get one full cycle.
but that's a quarter, that's at, that's
So
here.
it goes up after 11.
That's, because this is a quarter of those, right? So that's from here to here. From here to here, it goes to 11. Right?
Once you have your graph, you're confident about your graph, then you can go on to
Like
C
if
and
this is
C.
half of that, right, it goes to here, no?
Something else.
But that's just straight down. Because if half of it is 11, then it has to go straight down. This is 5.
So we have to determine the amount that
So this is 1, this is 1, this is half is here though.
is too high. Not
1 point, okay. So then it goes back to what it was.
Okay.
This is 6.
So, well, you got those right.
If you want to find the height, you have to divide by 4.
What?
So you start with feet, which is
That's great.
17. And 34.
Yeah, well, that's really important, because we spent a whole day talking about what
So it starts at 13 and goes to 20.
how does the change, how does it
And then
change?
at 34 comes back to right?
Okay, I think most people got it now. Most people got it. All right, now go on to B and C. Go on to B and C. Oh no. I mean, yes and yes.
Oh, my lines, I know. But I don't think curve lines. I can do that. I can fix that.
You can try. Yeah.
Let's read 17. I guess
Why is it a technicality on my job? So 51 from 80, at 81 it goes to 13, and then it's here we start.
What's the period supposed to come down?
it's the period.
Today?
The period would be 69.
6.
69.
This to me should be 2.
The period's when it changes, it says it's 6. Looks like
51 from 87 should be 2, and then you come back up.
He didn't do the X, he just did the Y's.
Unless you're including it to be 13. It's one of the two.
No, you're right. You're right.
It's 11. Oh.
That's fine.
No, because even that's too long, because that's like 7 on the stage.
so those aren't the 10s.
No, they're just numbers.
Well, there's nothing here about the number, the same
They're not in the 10s.
Then it goes to 2,
Oh, that's the first number that goes to.
right?
Yeah, the first number.
And then it goes back up to 13.
It goes up to
17
17.
something. So then it is in the 10s.
But then it doesn't go all the way to
Yeah, when I try to do curve lines, it's retarded.
It goes only to 34. It's just wrong. The X is wrong.
Define function represents. This is a bucket.
The bucket seat.
Should be equals data times the radius, which is 11.
So C is like review. C is going way back to the beginning of
Define
the
function.
module. You get it in terms of
D is and registers up on the
No,
data.
okay, in part B. So, sine or cosine?
It's
Okay. What's the input here if we want it as a function of the angle? What are we going to input into sine? What's that? 2 pi? That'll just give us a value then. That'll just give us a number. So what is the argument? So in terms of x, what was the argument that goes into sine if we want it to be a function of theta? What's that? Theta? Okay, so if I'm graphing it here, yeah, it's just x, right? If it's in terms of theta, that's what sine takes. Sine takes Angle in radians, and if we're graphing it, here I have to put x, okay? Do we want the output in radius lengths? Or in feet?
In radius.
Okay, so the output in radius lengths or feet? Is it radius lengths above the water? No, feet above the water. So I will need 11. And then what's left? Okay, so here's the so did some of you say plus 2? Yes, some of you did. This is the most common mistake. Oh, the bucket is going to be up 2. The bottom of the wheel is 2 feet above the water, right? So we're going to raise it up 2. So there's the graph I just graphed. What happens when you raise it up 2? What gets raised up 2? Yeah, the whole function. But what do we think about raising up?
It only starts at 2.
Yeah, so it's just the midline, right? The midline will get raised up 2. And is that the behavior of the bucket? It shows the bucket now going underwater. 9 feet. It'll make it down to 9 feet underwater. If you raise it up 2. So had we not made that graph, many more of you would have put plus 2. If we would have just gone right for the equation and not seen the graph. But it's the midline that we want. That's how much we raise it up. So how far? 13. So it's just, I'm just pointing out, it's the most common student mistake. They see that the min is moved up 2, so they add 2 to the function, and then they go on to the next problem. If you do that, it won't even be close. Your bucket will be underwater half the time, or a big part of the time.
Adds to the excitement. They add someone else on.
What's that?
But it adds to the excitement.
Well, this is just a bucket of, collecting water. Okay. Questions on this problem? How about in terms of the distance traveled? So really then we have to get angle in terms of distance traveled. So how do we get, this is review from back from the beginning of this unit. How do we get angle? So if the thing rotates a distance, is it D? Call it D. Then how do we get angle? How do we get angle from D? Because that's in the expression that we'll put in into the sine will be something that concerns D. He wants D equals theta times radius. So what is theta? Theta is number of radius lengths. Number of radius lengths. And so then we need, if we want D in feet, then we need it times the length of each radius. So if each radius is 11, and we go theta radius lengths, then the total distance we'll travel is 11 theta. So that second function would be, what do they call it? G? Be G of D equals 11 sine of what? 11 theta. No? No. This what goes into sine is the angle. No. So we're doing it in terms of D now, not time. So we're doing it in terms of D. So what is theta in terms of D? D over 11. See, right? That's what we just worked out. Theta is D over 11. Or think of this, you can think of it this way. You go D feet, what do we need to put into sine? How many radius lengths that is, right? So if you had D feet, how would you get radius lengths from D feet? If each radius is 11 feet, so if we go 22 feet, how many radius lengths is that? 2. If you go 33 feet, how many radius lengths? 3. If you go 5.5 feet, how many radius lengths is that? 5.5 feet. It's half, right? So how do we get that? You got to divide by how many feet are in one radius to get how many radius lengths? So that's another way to think about it. Questions on this problem?
So the function that represents the distance above the water, for V, x is like an x value, or x is the...
Yours is going to be in terms of theta, right?
So it's the angle.
The input is the angle. That's what sine. Sine takes angle, gives out vertical distance above horizontal diameter. So now we got to move the midline up 13, and we got to make sure we have radius lengths. Or sorry, in feet. What's that?
So it takes angle and gives out vertical, what did you say?
Vertical distance.
Vertical diameter.
Okay, so take a look at. Go back to page 295 and let's read number 2. Back to the bike. So now what's happening is the pedal starts at the 3 o'clock position, and the wheel starts pi over 4 clockwise from the pedal. So that the tire valve is starting pi over 4 clockwise from the pedal, okay? And so every time the pedal goes around, goes 1 radian, so does the tire valve. So the amount of rotation is the same, it's just now the tire valve is starting at a different point. So I'll let this thing spin. So that's the situation here. So what you're doing is, the first thing you're going to do is, so every 1 radian of the pedal gives 1 radian of the tire valve. But the tire valve starts a quarter pi clockwise from the 3 o'clock position. So that's the starting point, okay? And then, but the angle swept is the same for both. So the first thing you're doing is filling in the table on the next page. What you're going to do in this table is don't use your calculator. You can write expressions in here, and you want exact values. So no calculator. Just write in an expression that says what the tire valve's angle measure is, given the pedal angle's measure. Okay? So write an expression in there. No calculator. We want an exact value. And once you figure out what's going on, then the table just creates itself in about 30 seconds. Or you can use expressions. So you can use expressions.
Like actually pi over
like
negative 0.
times and minus and subtract and plus and... Once you get the hang of the table, you just write down all the answers. Yes, right. But negative 5 or 6?
No, I try to erase it, but I don't.
Okay, keep going. So keep going. If you get the table, then keep going.
Basically.
Valve angle in terms of the pedal angle.
So like if you take the left side,
Well, I have back side.
Down. You're still going
No, the wheels going. Oh, it's-
But now we're in a particular spot where so the pedals at 5 or 6. Where is the That's not multiplier divided. Yep.
So once you hit the great clock,
Yeah.
does that change it to 2 pi, or is it?
You're making it a lot harder than that's it. Yeah, you did good. That's it. Just keep going. That's it. So how do we write the tire valve angle in terms of the pedal angle? What is it?
Minus pi over 4.
Plus, minus, multiply, or divide?
Theta minus pi over.
It's just pi over 4. Is it ahead or behind? Is this angle ahead or behind? So how will that graph? If we were to graph that, how will it imagine the graph? So let's graph the pedal first. Are we graphing sine or cosine? We'll just do sine. So what will the graph of the valve look like compared to the graph of the pedal? If it's behind. If it's behind, where will the graph of the tire valve come out? It's going to be shifted. If it's behind, which way will it be shifted? If it's behind, where will it be shifted? To the right or to the left? That's right. It's doing it later, and later is to the right, right? Later in angle is to the right. So if it comes later, it's behind, it comes later, it's shifted right. Because later in angle is down the road, right? Down the road. Okay, have a great weekend. Study for your test.
I don't think I'm actually